Here we are. A little more tangent line discussion, huh? You about sick of that stuff yet? You're gonna be a pro. You're gonna be a pro. For which values of x does f have a horizontal tangent line? For our function e to the x times cosine of x. What does it mean? What's it mean for a horizontal tangent line? If you were to have a function going like this. Wouldn't it be like these spots? Horizontal tangent lines? I'm gonna call these. That's not a graph, but just kind of throwing it out there. Those peaks and valleys would give us horizontal tangent lines. It's also where our derivative will equal 0. So here's the game. Horizontal tangent lines, take a derivative, set it equals 0, solve. Simple, right? Simple. Let's go. And it's not that bad if we have our, we got our values down, we understand trigonometry pretty darn well. I'm gonna be like, okay, no biggie. F prime of x, let's go find its derivative first before we set it equal to 0. So let's just do this. E to the x and cosine of x. Derivative e to the x is e to the x. Derivative cosine of x is negative sine. So let's do this one first. Let's go e to the x cosine of x. And then we're going to add it to the negative sine x e to the x. So let's write it like this. Cool. We found the derivative. This is where it was before I was asking him, like, hey, y'all, you probably don't want to get this stuff factored up and start getting used to these patterns and stuff because you're going to have to set this stuff equal to 0 and solve soon. Well, we're here. And this is a very, very straightforward one. There's little things that are in here. May not be straightforward right away for you, but in time, hopefully it will. So I'm going to yank that e to the x to the outside. All right, y'all. Here it is. We just got to solve for it. So by the zero product principle, it tells us that if e to the x equals 0, the whole thing equals 0. And if cosine of x minus sine of x equals 0, the whole thing equals 0. That's called the zero product principle. Fortunately for us, e to the x can never equal 0. The exponential function, that one I've been telling you should probably get that shit locked in, right? Those exponential functions that go through there, it has a horizontal tangent line at y equals 0, so there's no way in hell it can ever equal 0. Shoot, back here, we could have actually just divided both sides by e to the x and been like, get the hell out of here. Did you get that in your pre-calculus class, your college algebra class? That you don't divide out variables, but you sure as hell divide out exponential functions when they're set equal to 0, because they can never equal 0. So we can ignore that e to the x. We can go, hey, that cannot happen. So we lose it, and now we just have cosine minus sine is equal to 0. Maybe you just want to add one piece over to the other side. Maybe we add sine over the other side. So we're like, oh, shoot. Oh, this is fine. The slope of the tangent line is going to equal 0 wherever sine equals sine equals cosine. Yeah? Come on, you know trig, huh? Where does the sine equal cosine? And I want infinitely many answers. I want all of them. Every single last one of those answers. Well, maybe you don't like this, where you're like, I don't know where sine and cosine equal each other. That's multiples of pi over 4 when you're in quadrant 1 and quadrant 3. Because they're both positive in quadrant 1. They're both negative in quadrant 3. Maybe just take it a step further. Maybe you're like, I don't like the way you talk about sines and cosines. Why not? Maybe I do this instead. You're like, okay, cool. So this is, oh, it's where tangent of x equals 1. Now this might be a little bit simpler because we know the period of tangent is pi. We know the period of tangent is pi. So where does tangent of x equal 0? So this is where we could hit something with an inverse where you could use your calculator, but you'd still need a little bit more info to be able to inverse tangent to pop out that x and to say that our x value is inverse tangent of 1, but it's going to be plus some other nonsense. I'm actually going to write it in as pi k, and I'll give a little bit more info on that in just 1 second. Okay, I'm going to get rid of it though. Let's go back here. Where does tangent of x equal 1? Just give me one answer, and that's pi over 4. Inverse tangent of 1 is pi over 4. We found a value. This is the stuff that like all my trig students do, and this is like the last step. This is like the simple step in a large problem. Would be to answer this part. Tangent repeats every pi. The period of tangent is pi. That's how long it takes for it to repeat. Remember ASTC? So tangent's positive, then positive, then negative. All it takes is 180 degrees for it to start. Oh, I mean pi radians for it to start back over again. All right, you should know it. So the way we're going to write this in is we're going to say since the period is pi and we know it's going to repeat over and over, we say that it's pi over 4 plus pi times any frickin' integer. For k, any integer. We start to write like this, and we need to start getting chill with this and maybe possibly writing it. Fortunately, if you're taking a trig class, you've done this before. If you take a pre-calculus, you should have done this before, depending upon your teacher. If you hadn't, then, well, it's your opportunity to try and catch up, because we're going to write like this quite a bit with this, like plus pi k, or I think actually your text uses pi n. I use k, where k is any integer, and I need to write it in as well. I need to write it in math. K is the element of the integers. I know it's kind of screwed up my writing, but it's still the same thing. The element looks like that. There it is. That didn't actually mess it up. So the k, the element of the integers. Same thing as saying k is any integer. All right. Hey, took a derivative. We set it equal to 0, then we solved. Dope. Well, let's try one more with some trig. Let's try one more. Y is equal to 1 over 1 plus cosine of x. Actually, let's do this one. I'll do sine. I'll mix it up on myself. All right, now let's go find which values of x is the tangent line horizontal. Oops. Same question. So we just want to go find those values of x. So we'll take a derivative. We got a little quotient now. We're like, no biggie. We're like, low, 1 plus sine of x times the derivative of high. Oh, well, that's just 0. It's a constant. Times high times the derivative of low. It's just cosine. All over 1 plus sine of x. All squared. Beautiful. Lots of good work. Let's clean it up. We say y prime, well, that's just going to go away. That's 0, so we get what? Negative cosine of x over 1 plus sine of x, all squared. Well, let's set this thing equal to 0 and solve. Let's set this thing equal to 0 and solve. So once we do, we got great news. That denominator, it doesn't make anything equal 0 unless you're talking about a freaking limit. Multiply it over to the other side. There you go. There you go. Multiply it over the other side. Now I'm going to multiply by negative 1. So it's where does cosine of x equal 0? Cosine of x equals 0 with odd multiples of pi over 2. So we're going to write it in like this. X is equal to pi over 2. That's where the first one, cosine of pi over 2 equals 0. Cosine of 3 pi over 2 equals 0. Cosine of 5 pi over 2 equals 0. Cosine of 7 pi over 2. Cosine of negative 3 trillion and 1 pi's over 2 equals 0. All odd multiples of pi over 2. So we could write that in math like that. X is equal to pi over 2 plus pi k for k any integer. Because trig functions typically repeat upon themselves, huh? Maybe not all the inverses, but there is a lot of repetition. You know, like circles and unit ones and going around in circles. Cool. I'll see you in the next one. Limits are coming back in the next, and we're going to take like 175th derivatives and stuff like that as well. So a couple games, crazy ass derivatives, but they're all games. I'll see you in the next.